Hello and welcome to the second episode of Erlang Dev. I'm Roberto and I'm a software engineer at WhatsApp. In the first episode, we learned how to use the Erlang language platform extension for VS Code to run and debug Erlang tests through the IDE. The extension we've been using, the Erlang language platform extension, is just a tiny little wrapper around the Erlang language platform itself. The Erlang language platform, also known as ELP in short, is a project that we at WhatsApp have been working on for the past few years, and it can provide a lot of features for the Erlang programming language. As you have seen in the past episode, one of the most common cases for utilizing the ELP is to use it in the form of an LSP server, like a language server that sits next to the IDE, to the editor, and communicates with the IDE to give you features such as code completion, go-to definition, or diagnostics. But ELP is a lot more than that. ELP comes with a powerful command line interface, CLI, and that's what we are going to explore in this episode. So, the first thing that we need to do if we want to use the ELP command line interface is to install it. We can go to the GitHub page for the project at github.com/whatsapp/Erlang language platform. There is a link to the ELP website, and the website contains all the information you need in the Get Started section to install ELP. You can install it from binary, from source, and so on. In my case, things should be super simple because I'm using a Mac, I'm using the Homebrew package manager, and there is an Homebrew formula for ELP already. So installing ELP is as simple as typing brew install Erlang language platform. And the operation should be super quick for me because I already have the package installed, so I don't have to do anything. I can just run the ELP command, I can pass the -h for the help, and I can see the help and I can navigate the menu. One recommendation here is to have a look to the generate completions command in ELP. The Homebrew formula does that for you, but it's very convenient when using the ELP command line to have auto-completion for all the ELP commands and diagnostic codes and so on. How does that work? I can quickly show you. You would type ELP generate completions, followed by your favorite shell, for example, bash. This will spit out like a command that you can run to install your completion. And once you have done that, you can do things like ELP lint, diagnostic filter, and then press tab, and then you see all the possible ELP diagnostics and so on. If you don't do this, then you would need to remember how to type them, and it's a lot more work. So remember to install the completions together with ELP. The Homebrew formula does that for you. Let's go back to ELP. So now that we have the command line, as you might have seen, we have plenty of commands that we can play with. The one that we will be focusing on today is the lint command. So we type ELP lint-h, and we can see the help for the lint command. There are so many commands and options that there is not a chance that I can go through all of them in this episode. I will only cover the basic ones, so feel free to explore the menu and the CLI yourself. Here I have cloned the ELP project so that we have some Erlang code to play with. ELP is a formatter for the Erlang programming language. It's also developed at WhatsApp, and we will be using to run the ELP lint against some real Erlang source code. So, for example, we can open one of the ELP modules. The first one is ELP algebra. It's random Erlang module, and we can introduce a problem in our code. So let's define a macro. We call it my macro, and we give a random value of, for example, 42. And as you can see, the macro, we are defining a macro, it's not use, so ELP will notice this. But notice that I will not be playing with the IDE, I will only be using the CLI. This is just to have some, to show you the actual code we are examining. So the thing we can do is we can run the ELP linters against a specific module, and we say that we want to run them against the algebra module. ELP will run and will report that we have diagnostics in one module, the one that we specified, and it actually found like 14 potential issues. Here is the one that we just introduced, right? We have an unused macro. The code for the diagnostic is W0002, and the macro that is unused is called my macro. One thing that we can do with the ELP command line is that we can also like explain these codes. So we can pass the code itself to the ELP explain command that will give you a URL which points to the website, which contains a catalog of all the possible errors that ELP can identify, and will give you like an explanation of what this means. In this case, it's fairly straightforward. We are defining a macro, we are not using it, so it's a bad smell. And here you can also use the search to find for all the other diagnostics. For example, a very interesting one is the W0023, risk of atoms exhaustion. Click there. Atoms are not garbage collected in Erlang, and so generating atoms dynamically is probably a bad idea. And the error index that comes with ELP will give you like some tips and tricks on how to deal with this situation. Anyway, let's go back to our CLI. So now we know that we have an unused macro. Fine. What can we do about it? Well, the first thing we can do is that instead of seeing all the errors, we can narrow down the lint execution to a specific issue. So we can say diagnostic filter. I could either use the W0002 code, because that's the one that we care about, or I can also use my completion to say unused macro. It's the same thing. So here we definitely see like the problem that we are dealing with. And a good thing is that I'll do it again here so you can see it better. One thing that ELP can do for you is that it can often auto-fix some of these problems. So if we want to solve the problem, we can just say -- apply fix, -- in place. It means if you have an auto-fix available for this issue, please solve it for me. In place, like do it there, so that, for example, you can produce a diff directly, and you can open a pull request. And as you can see, that's what it did. Like we also see it in the IDE live, where we basically like removed the unused macro. But let's run the ELP lint command on the module once again. Apart from the problem that we introduced, we saw that there were a number of pre-existing issues, and one that caught my attention is this binary string can be written using sigil syntax. Let's see what this is about. So first, let's copy the diagnostic code, and then we can use the explain code command to get an explanation of the code. We open the website, and this will tell us that this is related to the fact that OTP27, a recent version of Erlang OTP, brought in a new syntax for string sigils. Essentially, nowadays, binaries can be written in two different modes. Like you could have, let me open an Erlang shell. You can write a binary as this is a binary. call this A, and A is definitely a binary, but we can also write binaries using a different syntax. So this is also a binary. And then you have, if we run the is binary B, we basically get the same. It's true. So what this warning is telling us about is that in a few places we have the old syntax. Now, in some cases, you may not want to use the new syntax. For example, if you are addressing older versions of Erlang OTP. But let's say that in this case, we would be okay with converting this. So let's run the ELP lint module against a single, the ELP lint command against a single RLFMT algebra module. This time we specify that the diagnostic filter that we want to use is this www0051. As you can see, we have like 7 instances of this issue. So if we run this with apply fix, we can also pass the in place, and this time we have more than one instance of the problem per file. So we need to pass an extra option, which is the one shot. If we don't do this, then ELP would only fix the first instance of the issue and will not process the rest. But in our case, we want to solve them, like all of them at the same time. So we run this, and as you can see, there were like a bunch of modifications. So in fact, ELP converted all the occurrences of the old syntax to the new one with very little effort. As you can see, like using the ELP CLI is a massive help for a developer. And I can think to like a number of places where this is extremely convenient. One is that you can enable the ELP lint command in your continuous integration pipeline, in your CI, in your GitHub actions. That way, if someone is pull requesting some code, or if you're making modifications to your project, you will catch potential issues immediately. The other one is that when you are dealing with changes to an existing code base, these ways it's very easy. You can find unused macros, unused records, unused record fields across your entire code base and fix them with a single command. You can also customize the linting experience because, for example, you may not want to be warned about certain linters that are on by default. In that case, I'm not going to cover it in today's episode, but you can add a configuration file to your repository. It's called the .elp_lint.toml file, where you can specify, you can customize your linting experience, and you can enable or disable certain linters. There was a lot of information for today's episode. I hope you had fun and that you are going to try the ELP CLI soon. Thank you for watching.